Good afternoon, everyone. I'm Chen, an assistant professor from the National University of Singapore. Thanks the committee of the 2020 Service Science Best Class Paper Award selecting our paper as one of the finalists. It is a joint work with Louis Yan from UC Berkeley Haas School of Business and Zheng Shao from the University of Science and Technology of China. Social reach fuels business growth, but reaching new customers can be costly. A famous example in this case is a company called Pinduoduo, which is one of China's most popular e-commerce platform that is growing rapidly and yet maintains a low cost. Founded in 2015, Pinduoduo has amassed over 0.7 billion active users at the end of 2020 and became a viral sensation. A key driver for Pinduoduo's phenomenal growth is its pioneering adoption of social e-commerce, which integrates online shopping with social media and effectively turns shopping into a game. At the forefront of Pinduoduo's gamification feature is its Help and Haggle campaign, which allows consumers to get the product of their choice for free through social sharing. A consumer initiates the Help and Haggle campaign by selecting her desired product, and then a 24-hour timer is started. The consumer shares a customer link about the product with friends in her social network, inviting them to help her haggle over the product price. And friends receive no material benefits and help on a voluntary basis. Each friend who helps click on the link, which requires no purchase, triggers a tentative discount on the product price for the initiating consumer. And if the consumer manages to gather enough clicks and cut the price down to zero within 24 hours, she gets the product for free. Otherwise, the campaign fails and the product reverts to its original price. The total price discount that eventually applies is all or nothing in nature. As a result, consumers cannot fully predict the exact amount of the next price cut, and there is considerable variation in the number of clicks it takes to win the product. Someone reported to get a free rice cooker after inviting 70 people. Someone just find it next to impossible to cut the price down to zero. It is clear that Help and Haggle promotes the product and boosts the firm's social reach as consumers effectively refer their friends to the firm. And yet it is less obvious why the firm should randomize price cuts and how to do so in light of consumers' dynamic referral decisions. And further, how effective is this increasingly popular social e-commerce practice relative to alternative programs? And this paper built a model to investigate these questions. We consider a multi-period finite horizon model of Help and Haggle consists of a firm and a consumer. At the beginning of the horizon, the firm sets the product price P and the probability distribution of the price cut amount for each successful referral delta. And the cost of the product is K. At the start of each period, the consumer decides whether to make a costly referral, like to ask a friend for help. Now, as long as the consumer refers, a referral cost C is incurred on the consumer side, and a reward R, which represents the benefit from social reach, is given to the firm. And if the referral is successful, like a reached friend agrees to help, which happens with probability alpha, then the product price is tentatively cut by a random amount drawn from the firm's pre-specified price cut distribution, and otherwise nothing happens. If the running product price is cut to zero before the end of the horizon, then the consumer gets the product for free. Otherwise, all the price cuts expire, and the consumer needs to decide whether to purchase the product at the original price based on her valuation V. And to determine the product price P and price distribution delta, the firm trades off the benefit of social reach through referrals, the promotion expense, which is incurred if a product is given away for free, and the profit from the product sales. Given the firm's decision on the original product price and the price cut distribution, the consumer solves a dynamic programming problem, which follows this Bellman equation. And the firm optimized over a scalar P as the original product price and a distribution function F, which is the price cut distribution over the functional space. And the firm's expected profit also follows a recursion on the time index T and is connected with the consumer's referral decisions in each period. And we found that when a price cut is deterministic, like each successful referral will guarantee X amount of price reduction, then the firm will reduce this X as the consumer's referral cost decreases. And this means the consumer will have to make more successful referrals to win the product. And this is very intuitive. But when the price cut is random, this is not always the case. And in particular, when the referral cost is very low, the firm finds it optimal to adopt a drastic or none strategy that either cuts the whole price to zero with a small probability or does not cut the price at all when the consumer generates a successful referral. And finally, we also compared Help and Haggle with the traditional reward per referral program, and we found that Help and Haggle is more cost-effective in acquiring referrals but can yield a lower total profit, which includes the sales profit, when the consumers are homogeneous in the product valuation and face a constant marginal referral cost.